Okay, so let's keep continue with our data structure chapter. Okay, data structure will tell us many different way to store the data. Why we need a different way to store data? Because when we're using different way to store data, it probably give you a different performance on different operations. So many of you will recall when we say the memory space, okay, we talk about a lot how use the memory, how make your memory reusable, very efficient and effective. Okay, so there's something like the garbage collection, memory pool, some conception we already discussed before, right? So um, today we're going to talk about the data structure, how using data structure to get a good performance on different operations. So let's see the example first. So as we say, this is a map, right? And this map gives us a lot informations. For example, this row tell us is only you can go from home to the market. You cannot go back because the arrow tell us you cannot, which means home can go to the market, the home can go to the clinic, home can go to the bank. But since there's no backward arrow, which means they cannot go back from bank to home. So basically, you can understand the arrow is the one way. Okay, so that's one of the ways you can to store this data. One of the ways you can use the coordination. Coordinations we just based on the location using the x and the y coordination to locate this different buildings, right? So, for example, the home we just have uh, x coordination is 361, y coordination is 125. Okay, but this this is the way we store the data. Cannot give us something about can we go from home to the market, or or can we can we go from school to the market? Because this only state the coordination didn't give any like direction, right? So then we introduce another data structure, which we just record the data structure about the using this structure. The first one is the original place, okay, and the last one is destination. Okay, based on this data structure, we can know from we can know the route from the original place to the destination, right? So for example, the home we the original place is a home, and the destination is market, which means home can go to the market, right? And this one home can go to the clinic, and the clinic can go to the school, and the home can go to the bank, bank can go to school, and the school can go to the market. Okay, so in this way, in this data structure, it tells us the direction, whether this direction is one way or two way, whether we can go from home to market, whether we can go home to a clinic. But there's some problem. Okay, so if we want to track how many route we can go, if you want to know how many place you can visit from home, how can you do in the data structure? So we have to count, right? You have to count the first item have to be the home, right? So you count from 1 2, 3, 4, 5, 6 until the end. Then you marked the original place is home, right? 1, 2, 3. So you just the place. So +1, +1, +1. Then you get 3, right? So it tells you the 3 route you can go, the 3 place you can go from home. Okay, but there's a problem. If you want to do these operations, you have to read every items in this data structure. Okay, you cannot stop here. Why you cannot stop here? Okay, obviously you say, okay, I just checked. There's only 3 data which is from home to the different place. But when you check this process, you just did is from beginning until the end, right? So if consider if you have the data about 1 million record over there, okay, so which means you have to read one by one the record and check how many places you can visit from your original place. So how we can optimize the data structure? There's another way, okay? So we list the original place over here and the list the possible place they can visit in one column, okay? So this big difference from this one and the previous one is we list the original one in one column and the place possible places in another column. So which means if some of people ask, like I want to know how many places I can visit from home, so which means you only need to check the one of them, right? And mark down there's 3. So once you find this record, it which means you don't have to go to the rest of them, right? Because the rest of them, there's no duplicate, okay? It's unique, then it's very efficient. Okay, compare these 2 data structures. You can tell based on different operations, you can find structure A is very good, is very fit to the operation, like looking for the route, looking for how many routes, how many places can go from home, right? But the structure B is not too bad, okay? Especially compared with the another structure coordination, right? So you can tell there's a big difference when we're using big different performance when we're using different data structure.